Okay, so this was the motor resistor prac, and the aim of this prac was to get this coil over here moving around in a circular motion. So here is a diagram of the prac, and over here is the battery, which acted as the power pack, and the current would come from there. Here is the ammeter, which would obviously which would show you the amount of amps. Here is the voltmeter, which would show you the amount of volts, and here is the coil, which was spinning around. When we did the prac, the results we got was 3 for volts, 0.2 for amps, but the resistance was unknown. So to find the resistance, you have to use one of these 3 formulas, and so we're going to be using the resistance formula, which is R equals V over 1. So then you have R equals 3 over 0.2, and since there's a decimal in the fraction, you times the top and the bottom by 10, which gives you R equals 15. And so the resistance was 15 ohms. So how this whole motor worked was that one side of the wire was scraped off by sandpaper, and scraping the wire with sandpaper caused it to remove the enamel. The scraped off part of the coil conducted electricity, and the enamel side would sort of act as a resistor. It would reject the electricity. The ammeter, when the ammeter reading was trying to be taken, the needle was swaying side to side because the enamel side of the wire would stop the circuit, and then the non-enamel side would start it up again. That's what caused the spinning of the coil not to be in a fluid and smooth motion, and it made it a bit jagged. If the coil was to keep spinning, it would eventually get hot and melt because the electricity flowing through the coil converts into heat, and the magnet would only attract the wire if it was charged with electricity. So if the wire wasn't charged with electricity, the coil would just stay still and it wouldn't move around. And